Hello everyone. So this is the problem given here. It says that a body is initially at rest and sliding along a frictionless track from a height h. As shown in figure, this completes a vertical circle of diameter AB equal to d. So you have to find the height h, right? This is the solution. We have to find the speed at point A. Okay. We know that the object completed a vertical circle. Thus, we can say that the speed at A was V equal to root 5gr, right? Where r is the radius of the object. Now, when we apply the energy conservation theorem, that is the potential energy equal to kinetic energy, the potential energy is equal to mgh, m being the mass, g gravitational acceleration, h being the height h from which it was sliding down. Next is half mv square equal to kinetic energy. Okay, so in this, m is the mass and v is the speed when the object completes a vertical circle. Now, what we do is cancel out the m on each side. Okay, so we are left with g is equal to half va square. We take g on the right hand side, giving the equation for h equal to half va square by g. Now, what we do here is we replace r by d by 2 because all the options in the question that are given to us are in the form of d, right? So when we put in the value for va square, we get 1 by 2 into 5g d upon g into 2. We cancel out g, hence the answer is 5d by 4.